All right, let's talk about taking your C# web app and really turning it into a cloud-native powerhouse. We're going to dive in and solve one of the most classic, most frustrating problems in all of software development. Oh, this phrase. Come on, if you're a developer, you've said it, you've heard it, you've probably lost sleep over it. It's the universal distress signal that a deployment is about to go sideways fast. So, why does this happen? Well, it's pretty simple when you break it down. Your laptop, that's your safe space. It's a perfectly manicured garden where you know every single thing, the OS, the libraries, all the settings. But the production server, that's a whole different beast. It's a wild jungle out there. You've got different OS patches, missing dependencies, tiny configuration changes, and all of that can totally wreck your beautiful code. So how do we tame this chaos? Well, the answer is a big shift in thinking. We stop shipping just our code. Instead, we ship our code inside a standardized universal box that works exactly the same no matter where you put it. And that universal box, that's a container, and the magic behind it is Docker. Docker isn't just some tool. It's a whole platform designed for this. It lets you package up your application and everything it needs to run. We're talking the code, the .NET runtime, all the libraries, into one lightweight, portable unit. It's really the ultimate promise of consistency. But you can't just poof, make one of these perfect boxes appear out of thin air. Like any great dish, it all starts with a very precise recipe. And in our world, that recipe is called a Docker file. Don't let the simple name fool you. It's just a plain text file, but it's incredibly powerful. It lays out the step-by-step instructions that tell Docker exactly how to build your app's environment from the ground up. Now, when you follow that recipe, when you run those instructions, what you get is a Docker image. The best way to think about this is as the master blueprint. It's a static, read-only template that has everything perfectly bundled inside. Your compiled C# code, the .NET runtime, everything. It's a snapshot, ready to go. And then, the moment of truth. When you actually run that image, you get a container. This is the universal box in action. It's a live, running instance completely isolated from the machine it's on, just doing its thing. Awesome, we've got our box. But hang on, in the world of the cloud, every byte counts. Size and security are a huge deal. A big, clunky box is slow to move around and gives attackers more places to poke around. So the question becomes, how do we make this thing as lean and mean as possible? The secret sauce here is a really clever technique called a multi-stage build. Here's the magic. First, you use a big, heavy-duty build box. It's got the full .NET SDK, all the tools you need to compile and publish your app. Then, and this is the genius part, you throw that box away and start fresh with a tiny, slim runtime box that only has the bare minimum needed to run your app. You just copy the final compiled code from the big box to the little one. And the result? A super tiny, super secure container with absolutely zero extra baggage. Okay, so now you've built this sleek, optimized, perfect little package. You're not just going to leave it sitting on your laptop, right? You need to put it somewhere safe, a central warehouse where it can be picked up from anywhere. And yup, you guessed it, that warehouse has a name, a Docker registry. It's basically a library for all your images. You push your finished image up to the registry, and then any server anywhere can pull it down. Docker Hub is the massive public one everyone knows, but most companies have their own private ones too. This is where things get really interesting. Having one perfect container is amazing, but modern apps, they aren't just one box. We're talking dozens, maybe hundreds of them, all working together. So how in the world do you manage all of that? How do you scale up when traffic spikes? How do you fix things when they break? You definitely don't do it by hand. No way. What you need is an automated system. Think of it like an air traffic controller for your entire fleet of containers, keeping everything running smoothly. And that air traffic controller, the undisputed industry standard, is Kubernetes. You'll often hear it called K8s, K8s for short. Its whole job is to be the orchestra conductor, automating the deployment, scaling, and management of all your containers, making sure they all play in perfect harmony. So how does this conductor actually work? Well, its most basic fundamental building block is something called a pod. A pod is the smallest thing Kubernetes will manage. It's basically just a little wrapper around your container, or sometimes a few containers that need to work closely together. For our C# app, it's usually one container inside one pod. Simple as that. But here's a pro tip. You almost never mess with pods directly. Instead, you tell Kubernetes what you want using a deployment. This is where you declare your intentions. You just say, hey, Kubernetes, I want 3 copies of my app running at all times. And Kubernetes just makes it so, creating the pods, watching them, and even replacing them automatically if they crash. Okay, one last piece of this puzzle. Pods come and go, right? Their IP addresses are always changing. So how do other applications, or your users, find your app reliably? The answer is a service. A service gives you a single, stable network address, like a permanent front door, that sits in front of all your pods and balances the traffic between them. Whoa, okay, let's take a breath. We've thrown a lot at you. Docker files, images, containers, pods, deployments, services, it's a lot. So let's put it all together. Let's trace the entire journey, from a single line of C# code all the way to a live, scalable service running in the cloud. This is it, the whole pipeline. It starts with you writing that brilliant C# code. Next, you write the Docker file, that all-important recipe. You use Docker to build that into a container image, and then you push that image up to a registry. From there, you tell Kubernetes, hey, go grab that image and deploy it for me. Kubernetes then pulls the image, creates your pods, and a service puts that stable front door on it. And just like that, you have a live, managed, and scalable app. It's a beautiful thing. Now, you might be looking at this and thinking, wow, that must be incredibly complex to control. But you'd be surprised. It really just boils down to a handful of core commands. You've got Docker build to make your image, and Docker run to test it out on your machine. Then you use kubectl apply to tell Kubernetes what to do, and kubectl get pods to check up on how things are going. The system is complex, but using it is surprisingly straightforward. So why go through all this trouble? What's the big payoff? Well, you basically get cloud-native superpowers. Seriously, you get consistency, which means the "it works on my machine" bug is dead, forever. You get scalability, so you can handle huge traffic spikes with a single command. You get resilience, with Kubernetes acting as a self-healing system for your app. And you get portability, the power to run your app the exact same way on any cloud provider or even your own servers. Look, once you get this flow, you've pretty much mastered the modern blueprint for building and deploying software that can scale to the moon and back. The tools are here, the patterns are proven, so really the only question left is, what incredible things are you going to build with them?